Welcome to this video on ROM and RAM, focusing specifically on read-only memory, or ROM. We'll be gaining a deeper understanding of this permanent storage type in digital electronics. ROM stands for read-only memory, meaning it's generally read-only and not easily written to. It's a non-volatile memory, retaining data even when the power is off. ROM stores permanent data, such as crucial system instructions, and historically, it was factory programmed during manufacturing. ROM's characteristics include being non-volatile, keeping data safe even with power cuts. It is read mostly by the CPU very quickly, but writing is difficult. It is used for permanent storage like the BIOS for booting. However, it is generally slower to access compared to RAM. As technology advanced, three main programmable versions of ROM emerged. These include PROM, EPROM, and EPROM, each offering different ways of programming and erasing data. PROM, or programmable ROM, is initially a blank slate. It is programmed once, by blowing microscopic fuses inside the chip, making it a one-time programmable memory. Once the fuse is blown, it cannot be erased, making mistakes permanent. EPROM, or erasable programmable ROM, is reprogrammable and solves the permanence problem of PROM. Data is erased using strong ultraviolet light through a transparent quartz window on the chip. It was historically popular in development environments for testing software. EPROM, or electrically erasable PROM, is the most modern form. It is erased electrically, instantly, and without UV light, and can be reprogrammed thousands of times without removing the chip. Modern flash memory, like USB drives and SSDs, are advanced, high-speed types of EPROM. In the ROM system architecture, the central processing unit can read data from the ROM via the data bus after sending a memory location through the address bus. However, the CPU cannot send data to the ROM via the data bus. ROM is used in several applications. This includes BIOS storage, firmware storage for hardware devices like smart TVs and printers, and in embedded systems such as microcontrollers and household appliances and cars. Comparing RAM and ROM, RAM is volatile and temporary, used for running applications and the operating system, with fast read and write operations. ROM is non-volatile and permanent, used for storing startup code and firmware, and is mostly read-only and slower than RAM. Real-life examples of ROM include the BIOS chip on a motherboard for booting the operating system, ROM in a washing machine microcontroller for digital cycles, and EPROM chips for the firmware that runs a smart TV. The advantages of ROM include high reliability due to its read-only nature, making it immune to accidental deletion and software crashes. Also, no power is needed to retain instructions, making it perfect for booting up cold devices. In summary, ROM is for permanent storage of crucial, unchanging data. It is non-volatile, retaining instructions without power. Its evolution has moved from unchangeable PROM to UV-erased EPROM, and then to the modern electrically erased EPROM. For a quick revision, RAM is temporary, like a rough notebook, and is cleared when power is off. ROM is permanent, like a printed textbook, and its instructions remain forever, with or without power. In perfect harmony, a computer needs both. ROM provides the reliable, permanent instructions for turning the machine on. RAM offers the lightning-fast, temporary workspace needed to actually use software and browse the web. Thank you for watching this video. We hope you keep learning and keep growing. Please feel free to like, share, and subscribe for more content.